আমার ব্লাউজটাও পরে আছে।
Good morning, sir.
Good morning, sir.
Yes, sir. Good morning.
Good morning, sir.
Yes, madam. Good morning. Okay, so namaskar and good morning to all of you. So today is the third day. In this third day,
Good morning, sir.
yes, namaskar, sir. So today is the third day. This third day, we have 3 lectures. You know. So first session, we have to start within couple of minutes. And this is very important topic for us because this topic is directly connected, majorly, I may say, majorly connected to our program title. So don't forget it, our program title is Waste Technology. And today's first session topic is energy from waste. Okay. And second topic, another very important topics today, that is liquid waste characterization lab. In this laboratory, we shall show you most of the important experiments which are related to liquid waste characterization through camera, obviously. And today's last session, we shall start from 2:30. And that is another very important topic for us. That is the biodegradable plastic in favor of solid waste management. Okay, now come back once again to this session 1. Once again, welcome to today's session. So I am happy to inform you, we are very much lucky because today's session will take our honorable director. And he is Professor Devi Prasad Misra. Now I would like to introduce our honorable director. Dr. Devi Prasad Misra, a professor in the Department of Aerospace Engineering and Design program, Indian Institute of Technology, IIT Kanpur, had joined this institute on deputation as the director with effect from 8 June 2020. He had held Indian Golden Jubilee Professional Chair in IIT Kanpur. He has been conferred with several awards and recognitions. He received the doctoral degree from IISc Bangalore, so one of the prestigious institutes, in the year 1994. His areas of interest: propulsion, combustion, computational fluid dynamics, and atomization. He has edited 5 textbooks and 6 edited books in the field of combustion and propulsion. He has published more than 232 research papers in international and national journals. And he has also developed an unique virtual lab, that is virtual combustion and atomization lab. He has undertaken more than 38 research and consultancy projects from various agencies, research lab, and industries. He has developed 6 online courses under Swayam platform, a national initiative of MHRD. And beside this, he has designed and developed a unique MOOC course, that is Introduction to Ancient Indian Technology on Swayam platform of NPTEL. He has published 2 edited books titled forays into ancient Indian science and technology, and glimpses of ancient Indian science and technology. Over last 8 years, he has delivered several invited lectures on ancient Indian science and technology and culture and tradition to more than 5.5 lakhs people across India to revive and re-establish ancient scientific and technological culture of India. He has also delivered several invited lectures on ancient Indian spiritual knowledge system by several organizations across India. He has written several articles to popularize science and technology among common people and delivered several lectures and discussion on TV and radio related to ancient science and technology and other topics. He has penchant for designing and developing eco-friendly and sustainable which are appreciated by people. He does dabble in Odia literature and has also 2 books in Odia language to his credit. He is well known as a motivational speaker and is very popular among youth circle. So on behalf of participant and on my own behalf, I welcome our director, Professor Devi Prasad Misra. Sir, just now you can start.
Mera namaskar. Is it audible?
Yes, sir.
I welcome all of you this important Atal program on waste management. And as I learned that from Professor Mandal, that this is a very important topic, part of the course. I was wondering what I will be doing, because a topic which is a very vast, and I have not really, good enough to talk. But what I would suggest that let us see as a learner what we can really look at, how to convert the waste to energy. Question arises, what do you mean by waste? Can anybody tell me what is the meaning of waste? Anybody from the
materials which are being, yes sir, good morning sir.
Namaskar.
Namaskar. The materials which are being discarded by human beings, we can generally say it as the waste materials.
Yes. So if you go back today, the West, have really taught us what are the West. If you go back to the ancient Indian way of life, was there anything West? Do they consider anything as a West? Can anybody tell me? This is because we are living in a country which is having a civilization since time memorial. But can anybody tell me, is there any West somewhere written in any literature? West subject. Eh? Is it there? Whether people categorize something as a West? No, this is West,
No,
this is
sir.
useful.
No.
No, right? Anybody else? Then why suddenly West has come? Because it has created in West. West is a West. Are you getting a point? So that is the crux of the thing. For example, like, how our ancestors were leading a life So that there was nothing, no concept of West. That means where we went wrong. Is it that material was there at the time? Is it without material can a human being live or any animal live, without material? It's not possible for any animal, insect, even amoeba to live without material. All are material, right? Even you may not be knowing the mind, your intellect is also considered as a material in ancient, way of looking at the thing. Anyway, I will not get into that philosophical aspect. But today, West is a, big problem for the modern life. Whether we are educated, whether we are civilized, whether we are developed or underdeveloped or overdeveloped or, in a primitive stage, that is a question one need to ask. So look at, you can see this picture. The picture is, this is a poor human being, I think having no cloth, only in the upper portion, particularly cloth not there. And this is the thing. If you look at, this is our globe. Any of you have seen the Earth or maybe satellite picture of Earth? That will be better. You cannot see an Earth picture, unless it is a satellite. It looks to be very beautiful. I call it beautiful blue planet. Now, what I would call, it could have been maybe something 400, 500 years ago, but today, this is the same. It is the, ugly garbage planet, right? Am I right or wrong? Please look at the feeling. Okay, that is important. Now, what do you mean by waste material? Is the question. So if you look at waste material can be, as I think Subhangi, I guess, told that something which people cannot use it. They will refuse, Okay. There are, in our country, the refugee is a big problem. Okay. A lot of outside people are coming and then occupying the land, and then, it's a lot of problem. And this is a problem across the globe, and we are facing more problems. And of course, at that time, if you go back to earlier days, there was nothing like refugees. Okay. People will come and go, but, they don't do damage. They don't go and, occupy a land unless they are invaders, right? But common people, today common people are becoming also invaders. That is the mindset. And also there is a mindset the people becoming a grabber, a land grabber, you call position grabber. There are several kind of grabber. All we want to grabber this. Therefore, this West is coming into picture. And what are the causes for causing the waste materials? Question arises, can any refuse or the waste be used as a resource to others? Right? That is a question which we'll be answering, trying to look at it. Now, this is, hazardous waste. One way of looking at it. Mining materials, which is the waste. Is it mining is a new thing, concept, or it was there in ancient India? Can anybody tell me whether mining was there in ancient India? Ancient India means before 1200, CE. Can anybody tell me? We generally call it the AD, okay, 1200 AD. Because why I'm talking 1200? Around 1000 kind of things, 1200, or maybe you can say 1000 AD. It's better to say 1000 AD. 1000 means where our whole country was, or maybe invaded and then captured most of the portions. And by 1200, it is almost all captured, okay, by the invaders, and we became, what you call, country ruled by the other people, right? And that was a great social, political, economical, and then, change, and which we are still following because we are still having a mind of a slave. So the mining materials, whether mining was there before 1200 or before 1000, let's say 1000 CE. Any idea? Some of you might be thinking, hey, why should we know this thing? We are in the 21st century. Why we look at the back? Why? It is the wastage of time, right? And what is the do with this waste material? Yes, it is important because present emanates from the past and future emanates from the present. So therefore, you need to look at the past. You look at the life because everything, whatever you do is for life, nothing else. Okay. So mining was there or not? I think only how many participants? 50 participants there. I'm not getting an answer. You can say all of us are engineering fellow. Why should you look at history? Am I right? No. You have lived, you have taken birth in this country. So therefore, you should know what was there. It's important to know. Okay. And you can also look at where we are going wrong today. Right? Therefore, it is important to know. Okay. So, fly ash, you might be knowing because we are having power plants. And these power plants are coal-based. And this coal, whatever we use, and particularly Indian coals, which are not being used today, there is a problem. Like we're importing a lot of coals. And although we are having reservoirs of coal, which can last for maybe 200 years, but we are not using. Why? Can anybody answer this question? Why we are not using our coal? Why we are importing? There is a problem, in your internet. There is a coal. We are not getting from outside. There will be power, won't be there. There's a lot of hue and crack. Can anybody tell me why we are not using our own coal?
Because Indian coal, the percentage of carbon is not more than 70, sir.
Okay, 70.
Yes, maximum in most of the places. What
Maximum
we
that
are,
you are saying. That's okay.
yeah,
Then it makes sense. Because that means what is contains carbon is not there because carbon is important. What is then why is there? Why we cannot use it? Because carbon is there, but that is not good enough. It contains something. Let me tell you. I think can anybody tell me what does it contains? Which is I have already given you answer. That is ash. It contains ash metal, like minerals and other thing that will be converted into ash when it burned. So this fly ash is a big problem for us. And there is a lot of things how to manage, and all our cloud, for example, like I'm in Kolkata today, and today morning I got up, I saw that the sun is not coming out. I was thinking why? Because it's a smog. Why? The temperature has dropped down, then smog has appeared. So this is a big problem. So fly ash is a big problem, and so also the pollution. So agriculture, dairy and agriculture residues, and agriculture is as old as your civilization. Yes or no? Do you know who is the person, which country is the first in agriculture? Any idea in the world? Can anybody tell me? Okay. And I think you should some answer. This is a very simple question. I am not asking any technical questions or anything. It's a very common, sense. I'm asking common questions. Of course, you people are technocrats. You may not be knowing the, simple thing. You may be knowing complex thing. So, जिसको कहते हैं ना सहज ज्ञान आज नहीं है लोगों के पास. People do not have the very simple common sense using the things, but we know everything. Bigger things, but that is not really useful for leading a life. And coming back to that, the municipal solid waste, that is a big in the urban areas. In the rural areas, Also, we are having waste. Okay, lot of waste, solid waste. So what will be discussing basically today about the solid waste. There is a liquid waste. Industry uses a lot of liquids which are really, they don't know how to use that. Of course, maybe somebody else will be talking about that. I will be not discussing that. So question I will be asking a question like, agricultural residue was there earlier. Was it considered as a waste? Because India is an agriculture country, right? See, let me tell you one joke. When I was in college, I used to ask one of our president, I will not name, he was not knowing very good English. He went to a foreign country, some few, maybe 30 years back. And then he asked, somebody asked, hey, what is your culture? That fellow could, then understand something. Little bit English was knowing. So agriculture is a, culture of our country. So at that time it was a joke, great joke. Like we're thinking, what this fellow doesn't know, and he is talking something in a foreign country, and it's this thing. But today, if I look at that, it is really a very great thing he has talked without really understanding. And agriculture was the culture of this country, according to my present understanding. But that means the only way, one of the way, I can't say only way, there is a only way of generating the resources was the one of the most important way of generating resources was agriculture in ancient time. Although today it is a marginalized. But keep in mind that without agriculture you cannot do. And having said this thing, let me tell you, today our country is going from very bad stage to the worst situation, because the agriculture today is going to hands of the very big people. Okay, so it is already gone. It's like our Americanization. So therefore, they think in different way, and our values or the ethos are different way, and it is a total in confusion state. Let me tell you. And we are going from bad to the worst. Although our Shastra says, Asato ma sadgamayo, tamaso ma jyotirmaya, nritting mang amrutam. We should go from bad to good, but we are going in a reverse way. Why? Because we are educated. Are you getting my point? Therefore we are going in a wrong way. So now that is a waste. Today it's considered as agriculture residue is a waste. I will be talking about that also, how to handle it. Of course, these are the ideas. What is the origin of waste? What is that modern people are saying waste? According to me, if you live a life as to the principle governed by our ancestors, there won't be any waste. Okay. So if you look at origin of waste is mining, like waste rock, drilling, mining water, chemicals, and a lot of things are there, and agriculture, absolute pesticides, fertilizers, that is all waste. Because, like by this agriculture of chemical agriculture, we have spoiled the people, spoiled the entire, environment, water, air, soil, and the human being, and also all animals. All animals are affected by the, what you call these chemical fertilizers, pesticides, insecticides, and rest of things. I don't know. God only can save us. No human being can save us. And that is the problem with our technology. I think I would request all of you to please mute your mic. Okay. And plastic and container, plastics are very much used, like manure, slaughter, like we cut, there's a pink revolution, the, what you call like animal slaughterhouses, and it's too much, it's increasing at a rapid rate. And we are, importing. I told why should we do that? Because you want to have money, foreign exchange. So there's a lot of things are going on, and and also the processing of the agriculture, and the well processing itself, you spoil the food, and there is a lot of residues. Industry, textile, plastic, ash, nuclear waste, others. And of course, there is an important thing, I think it could have been written here, because it's there, electronics. Electronics is here. Municipal solids, the electronics, medical waste, tires, and others. So, and construction, of course, concrete, plastic, wood, metal, glass, and several other. Wastewater treatment, sewage sludge is a very important, problems, and solid waste, chemicals, and others. So these are the roughly I'm talking about the origin of waste, and there are several other things. Now, if you look at present status of waste management, kind of things, the estimated waste generation is something 150,000 metric ton per day. I think this is a too small kind of thing, and it is rapidly going and 0.6 kg per person, per capita, and every day, and it will be much higher number according, because the lifestyle is changing, so therefore it is increasing. Earlier days it was very, very low. Okay, if you go to Western country, this waste generation per capita is, like per capita energy consumption indicates the development. Similarly, per capita waste generation indicates the extent of development you have made. What a ugly definition people have given. It should be other way around. Now people have realized, Western people, but we are not realizing, because like we we basically catch the bus late. They have already cut the bus earlier of development maniac. It's a development maniac. It's not a development. It's basically destruction. India generates 26,000 metric plastic waste on a daily basis and 96 tons of trash every year. And waste collection efficiency, bigger size is what is they saying, waste collection efficiency. This data I have taken from somewhere, but I think that may not be the right, because I have seen a lot of waste are lying in the streets, 70-90%. Small size town is 50 to 60%. And so this is, if you have total collected waste, only 20%. Of course, this is, I agree. I mean, like lost of 80% are dumped in landfill sites. You might have seen each city are having, and villages is worst. And if you go to the all roads and everywhere around all dust, we are basically a country of, dust, what we call waste. So that is because our lifestyle, is not really that disciplined. Therefore, we are. Local authorities spend less than 5% of budget on waste disposal. Maximum cost is incurred to the street sweeping, collection of transportation. These are the big problem with association. Why to have waste management? Then let it be there. How does it matter? Doesn't matter. The way we think. Okay. Why should we have to manage the waste? Any idea? If we will not manage, what will happen?
Environmental degradation will happen, sir.
Yes. Very good. Anything else?
Everywhere you will get the garbage.
Yeah, we are in the deep garbage.
Yes, sir.
Okay, what else?
Sir, due to hazardous material, drug resistance microorganisms may occur.
Yes, you are right.
Uncontrollable
means,
pollution.
Pollutions. See,
Uncontrollable pollution.
Uncontrollable. If you look at all the cities of India are polluted to that extent that according to WHO, you cannot live, except one city in the northeast. Okay, that is the situation today, because we have spoiled water, we have spoiled air, we have spoiled what you call soil, and all whatever the lifeline, we are all polluted. God only knows what will happen. And sometimes I think we are alive. Oh my God, this is a great thing. So that is the situation, and it is a man-made. Because of the corona, when it was locked down for maybe 2-3 months, pollution level, all those things, at least air pollution, other things has dropped down. That means it is man-made. It is the we have created. It's not that, we are basically the human being, we call ourselves educated, but look at poor animals, poor organisms, poor birds, they are affected. That means we are really torturing them, and we are intelligent and we are torturing our own people, and we become like a bhasmasu. There is a bhasmasu. We are killing, self-suicidal, kind of things we are doing. And why? What for? Not development. Okay. The protect human health, improve the quality of life among people in rural areas. What about urban area as well? Okay. To reduce environment pollution, make the rural area, that's why you need to promote recycling, reuse both solid and liquid waste, convert bio waste into energy for ensuring greater energy security at village level. I don't know, village is not there. All are cities now, so there's no village. Are you getting the which was the basically the heart of the India was village, but village is not there. That is a very bad, sad part of this thing. And to generate employment for rural poor by offering new opportunities, these are the things what people are talking. So these are general thing you might be knowing. But let me tell you, I'll be talking about health hazard. The unsanitary condition due to accumulation of solid waste is going on. A lot of things. Epidemic outbreaks. See, that is a very important thing which is happening. And disease, cholera, diarrhea, plague, dysentery. So dysentery is having a lot of people now. Jaundice, a lot of infection, decomposition, putrefaction may occur. Intolerable odors, waterborne disease such as gastro and cholera. This is gastro, like a lot of people are having gastric problems, a lot of people are suffering, right? And so therefore, because of this health problem, one has to look at it. And so also the pollution, so also the life is at stake. Now, what are the ways? That is the questions. And okay, let me classify the solid waste. I'll be like biodegradable, which can be really decomposed by biological processes, that we call it biodegradable, either in the presence or in the absence of air, right? There will be anaerobic and aerobic by process, like your kitchen waste, animal dung, agriculture waste, and that. Now I'm asking this question. See, this animal kitchen waste, animal dung, agriculture waste was there earlier days. Plastic was not there. Okay. But how our ancestors were managing? And non-biodegradable waste which cannot be decomposed by the is called non-biodegradable, like plastic, iron, or any metal, nuclear, and waste and other things, which is not biodegradable. So this is the one will be recyclable, other is non-recyclable. And for example, now people are talking about recycled plastic can be recycled, but we find that plastics are being, and even we have not only spoiled the land, but we have also spoiled the what you call sea, because sea is the which governs all the climatic conditions, and because of sea we are living. Okay, that's why you might be knowing in our mythology that Samudre Basate Lakshmi, that means the Lakshmi means prosperity is lying in the Samudra, like in the sea. So therefore the sea is very important, Samudra, but whereas we are spoiling all our not only Indian Sea alone, but other seas also, like all are being spoiled. So non-recyclable, like TerraPak, carbon paper, and other things, that will be basically can be what you call thermocol. Thermocol are we abuse rather, I would say, too much, and then we are taking food in thermocol. I always say, what is happening? That. So I think kindly mute your this thing. I think I'm getting some problem.
Sir, I am controlling, no problem, sir.
No. There is a something I shifted this line that is not. Okay, now it is working fine. So if you look at, I have already discussed this thing. I think I will not spend time on that. Construction waste, agriculture waste, domestic waste, factory waste, and food and waste, bio medical waste. And this is very important. Biomedical waste is too much is going on because a lot of people are undergoing treatments. So electronics waste and nuclear waste. So I think this I have already discussed. The one is hazardous waste. This is a little different way of looking at one as biodegradable. The hazardous waste, non-hazardous, and radioactive waste. Like it's a what I learned. I may be not be right. I wish not to be right. That a lot of radioactive waste are coming from other countries to us to be dumped here. And this is I don't know whether I wish that if this information must be wrong. So industrial waste, electronic waste, and so also electronic waste. A lot of things are coming, and I got some data. And it's not that we are only making. They are also the Western people are sending because we are basically want to make money, and then we are getting them various ways, smuggling rather kind of thing that is going on in our country because our country is degenerated and we don't have a feeling for our own people, own thing. Only we understand money. So that is on an average scale. Okay? Don't say that everybody. So that is a very bad part. Other material like glass, plastic materials are there. So what is the waste management? If you look at it, is a systematic approach of device collection, transportation, disposal of garbage, storage, and other waste products. Okay. So and how to do recycling and reusing. This is a terminology which is used very much nowadays. We are talking therefore waste removal, waste treatment, waste transportation, and storage and collection and landfill disposal, which is all of us aware. So coming back to that, what is important? And in this, you please look at this. One is the disposal. If you could dispose, it will be very good, but you cannot dispose a lot of things. There is a energy recovery where today's talk will be discussing recycling, reusing, and minimization and prevention. If you look at how to prevent is a question. How to minimize? If you look at this top portion is the listing and least favored is these options. What you call disposal, and then energy even conversion is not good because that costs a lot of money, a lot of others. And most favored is this. That means minimization and keep in mind that India is a populous country of maybe 135 crore plus, and by this 2021 that census, it may go across 140. That is my my guess. All right. Now where to go? And tomorrow it will be 150 crore. This is a very tiny land. Okay. And also with the climatic change and other problems, the sea will be rising, a lot of land will be shrink, like what is the future? Future is very gleam. Now how to go unless you do something? So approach towards sustainable development. What do you mean? That people are talking about sustainable. So sustainability is basically a development model that meets the needs of the present without compromising the ability of future generation of media. See, the kind of consumption what we are doing today in our country and other countries as well is too much. That the earth cannot really provide. Therefore, the earth is crumbling. Earth is crying. Mother Earth is crying. Other day I was telling that, like this global warming, I was telling to people, look, Mother Earth is now having fever, right? Fever means, sluggishness will come and no activity, like a lot of things. So it is not only the human being, but all parts of it. So if you look at it, it's a very sustainable, is a very tiny intersection place. Now, whether we are talking and we are doing. And if you go back to our ancestors, how they were doing, whether they were talking about sustainable, they were living like a sustainable life. Can anybody answer this question? Whether they were living a sustainable life or they are talking like the way I'm talking, like, we talk and spend a lot of time, engage people for, discussion, whether they're living a sustainable life or not. I think you don't know. I mean, either yes, or you can say no, or you can say I do not know. I think you people are not really.
Sir, please repeat the question, sir.
Question is whether our ancestors were living a sustainable life or not. That is the question.
Yes, sir, they were living a sustainable life.
Sustainable life. Then why we are not living a sustainable life? Because
sir, yes, sir, as you said, we are educated, but we are going from good to bad. Hypothetically, we are calling we are educated, but we are not basically. We are polluting the environment more.
Actually, yes, you are right. We are uneducated, certificated person.
Correct, sir. Correct.
Uneducated. Okay, and the whole country is uneducated according to me. I mean, except few people, their numbers are very. So basically, approach towards is energy. What you'll have to do, you'll have to basically waste material to generate some energy such that electricity, heat, and other things can be utilized. So I think I will skip this portion. Already this I have discussed. The garbage includes waste and other degradable organic material that we call garbage. Rubbish including waste except food waste, right? Any other combustion, refuse both garbage and rubbish together. Litters, like whatever we discard, wrapping. You see, today is the packaging. Packaging industry is growing. That is a big problem for to generate garbage. And if you look at the municipal solid waste, this is about something the 3.5 million tons per day currently generated with it is going to increase 6.1 million tons per by 2000. And India has a potential of 3000 megawatt energy from municipality solid by 2020. 20 is over. I don't think we have achieved this, right? And of course, benefits already because we can generate some kind of energy. And whether it is challenges is that you will have to have a technology which will be feasible and like you can get some out of it, otherwise it's wasted. And the problems are because high capital cost, maintenance and operation cost, and resource generations, climate conditions throughout the year. That is also bigger challenges in developing the technology what you can use. So as I was telling that, these are the world kind of thing. India is something 0.57 kg per capita per day kind of things, whereas the USA is highest up to Bermuda. You might be knowing that is a very tiny place, but they are using the highest. So if you look at the developed country, Russia, Brazil, Japan, they are higher. That means it indicates they are developed, except of course Bermuda may not be a developed country, but these are all developed countries. But our ethos, Indian way of thinking earlier does not today. Today is a change country, and in a negative way. So less you consume, you are considered as a celebrated person. For example, like any our persons, they call it yogi. They use very minimum. Even today also a person is using minimum amount of material because we are not in favor of materialistic way of life. We are in favor of spiritualistic way. That means use minimum, because why you want to do that? You are using the nature, right? You should minimize the use of mother nature. So when you take care of mother, you should not really exploit the nature. The whole philosophy of Western is that you want to win over the nature, and therefore, like you want to, use that as much. This is a materialistic way of life. This is a profit. They suffer, and we are also. I can say all of us are suffering from the profit maniac, material maniac. Like it's a kind of maniac. Mind has been really spoil. So coming back to that, what is the projections? Projections that, MSW, that municipal desalination, by, this is the green is something populations and land requirement will be very high. And this is been going on increasing. This is the general of land required for populations. So therefore we are in deep trouble. And if you look at the Delhi is highest, having the 10 Indian cities West generation, something lakhs of tons, for this thing, 36 point. And then Jaipur is having, if you look at the, of course, Bangalore and the bigger cities, bigger problems. So that is the thing what I could like to draw the conclusion from here. Now, the projected West generation by region wise, if you look at the South Asia, East European countries have low this, we are going to East, going to, go up. Of course, East Asia and Pacific also, this will be, going across the globe. So therefore, how to manage is the question. So I think this slide I will just see, but only thing, one is organic, municipal solid waste, organic, recyclable, and inert. And what we can do is basically manage this organic. And plastic syringe or other thing, it can be recycled. So you can use these organic things, which is having CHO. Therefore, that you can, we can consider this as a biomass. That is that can be converted into the energy with the technology what I will be talking about. So the type of waste already I've talked about. I think I'll not, but only I'll tell you the time duration for this thing to disintegrate, kind of thing, degenerate. Organic waste is a week or two, that is very good. Paper is 10 to 30 days, and cotton cloth is 2 to 5 months, and wood 10 to 15 years, woolen items 1 year. But if you go to the plastic, it's several millions years, and tin metal, of course, something 500 years, depending on the metal. And glass bottle and the nuclear waste, is not there, but that is a very, very long time. Life cycle, is a very, very long time. So if you look at the, I will also ask you the question, what are the way people are handling the cotton earlier days? And today, of course, you won't get a cotton cloth. All are mixed with the plastic. So therefore, this is not cotton cloth, not 2 to 5 months. It will be something maybe, maybe order of 100 years, 200 years, because to go to the last level. Because most of the cloth, even if you go to Khadi, you will not get 100% pure cotton. Okay, it's very difficult because I do use those cloth, but they are not. So now, if you look at, as I already talked about this thing, this is the most sustainable is the waste minimization and kind of things, and the least sustainable is the disposal. So Indian perspective, you look at the good part of is this that biodegradable, and this is basically recycled 20% and inert is 20 and 8%. But if you look at the developed countries, the organic waste is very less. That is the beauty of our country. But unfortunately, we are moving towards now from biodegradable to the less biodegradable or kind of thing, or less organic materials because of our lifestyle. And how to go about it? Go about it is the incineration, that is the pyrolysis, incineration, combustion, gasification, anaerobic digestion. This is the way how we can really convert this into basically energy. And if you look at pyro, means basically fire. That is the meaning. That means you heat it, and then so that there will be degradation, thermal decomposition of material, particular organic, even plastic, even tire can be done. That is been going on. And elevated temperature, it can be 400 to 450 degrees Celsius. Let me tell you, there is the ultra pyrolysis, which can go to 1,000 degrees Celsius. Right? This is the endothermic in nature. That means you will have to give heat. And this is in the absence of oxygen, theoretically. However, you will have small quantities of oxygen. And it will be producing volatile gases like hydrogen, methane, and then higher hydrocarbons, CO and CO2. You can get a pyrolysis oil, which can be used, if you can really make it worthy, that it can be used as a fuel. Even a lot of things are going on producing liquid fuel using the process of pyrolysis. And this is the first pyrolysis, what they call ultra fast pyrolysis. And the residue will be biochar and charcoal, and which can be also utilized for various purposes. So if you look at in India, there are several people are working, but most of them are laboratory. So this is the laboratory setup which was being done by this Rahman et al. And what is then there's a packed tower they are made, and they do use some acetone as a fuel, and then to heat it, and then of course they will get the gas, and they collect it, gas bladder, and then the other tar and other things residue they can collect liquid here. But if you look at, they have used this in Hyderabad municipal solid waste, rags, tea waste, garden waste, waste paper. All they have done something, gas rate increases with a certain temperature, after that decrease. Right. And of course, the waste paper, this rags is having very low, it has to go for a higher temperature. Now, with these things, what you can do is that you can get various percentage of materials, and they have conducted in a batch process, but in the actual process, it has to be continuous. Otherwise, you cannot. And the 600 degrees Celsius, 1 hour, and they get some percentage of tar, liquid, and gas, and it contains carbon dioxide, oxygen, carbon monoxide, hydrogen, methane. So these are the things what it will be having. And of course, these are the air pyrolysis. There nitrogen will be there in the composition. But if you are using oxygen, then actual nitrogen won't be there. Therefore, the calorific value of the gas, what you will be getting, will be high. And here it is a very, very low calorific values. You can see that is the gas, and which is very difficult to use. So let us look at a typical schematic of, like a kind of pyrolysis reactors. The thermal recovery one can have, but this is you'll have to process the municipality waste or the any other agro waste. It can have various kinds of reactor. I'll be talking a little later on. And these gases has to be collected, condensate, and then it will be purification, and then it can be connected in the pyrolytic oil and carbon pile and gas cleaning. It can be use this also to give it as a boiler and other things where you can generate some power, provided it can be steam engine, it can be gas turbine. Of course, gas turbine is a little difficult, but generally people use steam either in the engine and any other application. So that way we can generate the heat. Let us look at a combustion. Combustion is basically you will have to use these as a fuel because it's having a CHO kind of thing. So therefore, it can be oxidized either in the presence of air or oxygen. They're exothermic in nature. Therefore, it will be producing some heat, and the product will be carbon monoxide, carbon dioxide, water, and of course the solid waste like ash and other things will be coming. And this heat can be utilized for the purposes of this thing. And there are several reactions. I think I'll skip this portion. There is nothing to discuss. And then this is the incineration. Incineration is basically nothing but the combustion. But it is can be open, it can be closed. Whether this technology, which was now talked about particularly for organic waste, or the waste containing organic materials, and this is being used, and then incineration is a process which was basically invented by whom? Can anybody tell me? Which country invented the incineration in the world? First time. Any idea? Definitely Western people. Am I right? Yes or no? I'm asking you people. Is it audible? Am I audible?
Is sir audible,
Yes,
sir?
sir.
Yes, sir, audible.
Okay, fine. So what I was telling, which country really incineration? Okay, let me give answer. You people may not be knowing because today I feel the Indians are not living in India. You know, whoever are living in India, they do not know about anything. See, this country invented the incineration. Why? You know, if a person died, that body is incinerated. Yes or no? And that culture is there in this country. When? Since when? Since the human being are there in this country. You know, it goes back to something around maybe at least 6, 7, or 8,000 years. You know, and there is evidence for that. And till today also we are following. Are you getting? Suppose a dead body. Oh, your skin sharing. Okay. So, but whereas the methodology what we use today, earlier days, and today, you know, there is a lot of, you know, and we have not never developed a design, you know, how to incinerate a human being, particularly dead bodies, not human being, not lively, not living human being, you know, dead bodies. And that is there since, and then of course we have not, but nowadays we are talking about generating industrial scale. So what we use basically to material, generally rotary clean is being used, and there is a afterburners, right, which will be used for this thing. And it can be solid waste, it can be liquid also. For example, spent waste, you can also use this here. And we can have a you know, initiate with the natural gas, any other gas, LPG, and you can have heat exchangers, and then of course you can have this kind of things, and then it will be going to the filters, and of course the scrubbers. And here, if you look at, there's a turbo generators which can be utilized to generate some power, and of course the condenser. This is a cycle one. There are various. It can use the steam, you know, power plant, or you can use a gas turbine power plant, depending on your technology, what you need. But so basically here what is being talked about is the steam generator, where steam is being used. And of course the steam technology is a very well proven technology, and it is a very cheaper as compared to the gas turbine engines. So let us look at a case study. And this is being done in basically I have taken for one paper here which I have shown, and through the production of solid recovered fuel, which, you know, basically you'll have to incinerate. And the date up to 11 and 7 night, you know, MSWI plants around the world exist with the capacity of 7 lakh metric tons per day in other countries like EU, European Unions, US, and East Asia. But Westman approach Japan is dominated by incineration, and in at least in the 2000 compared with the 1990. See, we had the first MSW power plant was installed in Trimapur, Delhi, with the incineration technology. Capacity was 300. It's something it started with 1987. Okay, when I finished my BTech, it's 30, 40, 35 years back. You know, capacity was 300 ton, and but so let us look at what happened. Western control process, burning combustible waste to produce gases, residue contain little or no combustion material. That is the idea. And the process convert the waste into ash, flue gases, heat, as I told. I think this is the usual process. I'll skip this portion. And there are several check and balance of incineration, like using material separation, because that is very important to remove hazardous and bulky. Using efficient flue gas clean system, that is important. And average annual lower, you know, calorie value, some 7 megajoule per kg, which you get, and never fall between 6 megajoule per kg in any season. Otherwise, it cannot really work, because also this is seasonal. But suppose in a rainy season, your material will be containing a lot of moisture. So therefore for this incineration, like preparing a controlled landfill or residue disposal, because that is a big problem, because even if you get some gas and out of it and it can be utilized fuel, but the large amount of residues comes out of that. That is a big challenge, how to dispose that. And there are applications, several of them, you can use for what you call various processes, like, of course, there is a plastic waste which can be utilized in the incinerations. And but at the same time, what will happen that you are using the hydrocarbons, therefore the carbon dioxide, will be also increasing. And of course, when you use polymer, then what will happen? The carbon dioxide burden will be lower, but the pollutants which will be coming out. God only knows what will be coming, because the polymer, there are several chains and which will be coming into it. So I think I will skip this portion. What you say Indian context, I'll talk about. The instead not much practice in India, and because of problem is that higher moisture content amounts something 40 to 60%, and organic materials are higher. So calorie value is low, and power potential to industry is reported 167 kilowatt per ton, with a net electricity efficiency is 15%. It's very, very low. And then, of course, the tariff of electricity in 2000, what they have gone is at 650 kilowatt hour MNRE has decided. That is the price what will be. And I think I just forgot, but like, let me talk about that. Timber incineration was basically, it was started with 1987, and they're supposed to started with a Denmark company. Plant was designated 10 municipal solid waste and 3.7. And plant ran for 21 days, trial operation, right? And with the least value of 1462 calories per kg. And the was in range of these things, like, but plant operator tried to, because that was not really very successful, and the kind of quality gas they are giving. And they tried to do anything, like Indians are always good in trying, but they didn't. They use diesel fuel, some other things, nothing really worked well to enhance it. As a result, this was abandoned. It went to court case and other things. That is all right. I will not discuss about it. But question is why? Why we failed? Because of fact that this company has designed for them. Even most of the power plant, let me tell you which are instance, is basically designed for their country. Even all the instrument what we use, designed for their country. And therefore, it is not fitting into, and we never have a technology driven, kind of things, education system, so that we'll develop our technology and then we can use, because depending on our coal, depending upon the material, because all are different. So therefore, that has to be done. And if you look at estimated annual emissions, which will be reduced by this kind of a, RDF incineration or waste pickers kind of things, what is estimated, this is estimated, kind of things can be reduced provided you use this kind of a technology that is being waste to energy and waste to opportunity. It was basically California University what they are. See what is happening, they will be doing this study for us. We won't be doing, okay? And then they will sell the technology, and those technology will fail, and then we fail. So this is the thing what is going on. I want to communicate this, that is important. And let us look at the gasification. The organics are the fuel, basically gasifications which can be done, like coal, ignites, and biomass, other combustible materials. Any material you can really do, which is basically having carbon, hydrogen, and other materials. Basically carbon and hydrogen. This will give, and that will be temperature is greater than 700 degrees Celsius, and mixture of hydrogen and carbon monoxide is the fuel, and the rest of the thing can be carbon dioxide, methane, very little amount, hydrogen, and sometimes the hydrogen sulfide, slag, as particular, all those things will be the byproduct, or the end product, you can say. Byproduct is a little different connotation. So there are various types of gasifiers are there: fixed bed, entrant flow bed, fluidized bed, like plasma gasification, Aerojet Rocketdyne gasifier. There's a company which are talking about black liquor gasification, catalytic gasification, biological coal gasification. See, if you look at, except maybe some fixed bed which is used for only for wood, we were having, because I had done some work a long time back, maybe 30 years back, and that was we are having, but those technology were not really on the field at this moment. Of course, some people claim it is there. And gasification process by which the biomass is thermally degraded under condition of insufficient amount of oxidation. That is very important. If you look at pyrolysis, is at the basically very, very less amount of. So as a result, you will get something. If it is air being used, you will get 20% hydrogen, and 20% around carbon monoxide, and then around 12% carbon dioxide and water. And if it is kind of a, and rest is nitrogen large percent. So therefore people talk about oxygen gasification, and that is a very costly affair, and we don't have really any indigenous technology to the best of my knowledge, and we get from outside. I'll skip that, how to calculate all those things. But here I would like to show you that, look, this is the equivalence ratio, air to fuel actual divided by air to fuel stoichiometry. The combustion will be taking place in the higher, this region, even little reach also 0.8 to 1.2 kind of things, where gasification takes place 0.2 to 0.4 equivalence ratio. And the pyrolysis, if you look at it, will be something below 0.2 or in between, that might be. So therefore, the temperature, if you look at, it's a very, and the equivalence ratio, you will be very low temperature where the pyrolysis will be occurring, and so on. So where combustion, you will get a very high temperature, because this is exothermic, you will be getting. So therefore, one has to control this temperature and the equivalence ratio and get the process. And generally, when you are designing, you keep that there will be gasification and there will be combustion, both will be there. So that, and if you want to, incineration, during incineration, both gasification and combustion will take place. But whereas when you are talking about the gasification, then it's you should not operate at a higher equivalence ratio. You should not operate at your reactor at the higher temperature. You will have to low temperature, and also pyrolysis and gasification will be taking place. So if you look at, this is the gases mole fraction, what will be at different equivalence, will be getting different proportion, right? And this is your nitrogen, which will be goes on this thing, and this hydrogen C1. So if you look at the kind of gasification generally occurs at where hydrogen is maximum, this region, and whereas pyrolysis occurring will be in this region, and combustion will be occurring here. So therefore, one has to look at it. I think I will just skip this portion. Let us look at why you will go for the direct combustion and gasification. Incineration is basically, air fuel control is quite inadequate in that, depending on the size and the shape and moisture. Therefore, it is a direct combustion will be giving little more problem. Whereas the gasification, the char reduction process permits auto control, and whereas the power control here is inadequate, it is a one can use very easily. And emission control is possible, but this is the superior, because you are converting the emission into a fuel, and then you can use. Whereas and also all the chars are taking, so that you can also use nowadays transport kind of moderate cost. This is a high cost because the technology is little involved, and combustion is a very simple process, and economical only at large power scale, some few megawatts, and this is at a smaller even level is possible. And the pulverized fuel, metal, vapor, oxide, anything can be done, but this is a lot of technology involved in that, cooling of the gases, and then eliminates of condensation, inadequate bonding, and other thing. So this involvement technology is in added technology, or the is higher. So turn down ratio is low here and it is very higher, and space requirement is high, and this can be compact, of course. I think because of this thing, and thermochemical conversion is 40 to 50%. Here it is 70 to 80% kind of. So therefore, the efficiency wise, the gasification is higher efficient. Therefore, gasification. And there are basically three kinds of downdraft gasifier, updraft gasifier, and cross draft. And I think there's a downdraft is divided into closed top and open top. And this technology is a very old technology. During the World War II, this technology was developed, in particular in Germany. And then it is, going over for that year. It is still continuing. And if you look at, there are two kinds of open, what you call top and open top down. This is the closed kind of thing. You can just go on air and supplying, and there will be a combustion zone, there will be reduction zone, right? And then there's a grate which will be making the material to move. And as I told that, there's a lot reaction will be going to carbon, with the carbon dioxide is going to CO, and CO plus this thing going to what? Carbon dioxide and hydrogen. And this, of course, don't think that this is the two reaction which will be going. No, no. There are several reactions will be going. This is the overall reaction, what can be really looked at. And this is the thing which basically our group has done. This is a biomass which is having a long time back, maybe something around maybe 30 years back. This is a thing. And there's a radiation shield, and there I've taken those the hopper which will be moving, and this is insulation. And the beauty of this thing that will be basically the gases will be going through this part, so that the heat will be transferred to this, so that it's a basically recuperative kind of a gasifiers, which is a fixed bed, open downdraft, open top gasifier. And of course, the thing is that closed top having 20 to 100 mm size, depending on, because you'll have to make a pellet, and there's also a thing. It's not a powder biomass can be used like. And top region volatile and region tar, because tar is very high in the closed top, whereas the open top is relatively low. So tar handling is another big problem in the gasification process. And this is the updraft gasifier, where the heat will be going this way, and then you will be taking the gas. In this case, what is happening? This is the pyrolysis will be going on here, because the gas is going, and then it will be also taking some of the moisture and everything, and is useful, cannot be used for engine application, because tar will be very high in this case. Therefore, to generate power using piston engine or in the gas turbine engine can work, but thermal application it can be very. So this is the cross draft, where the air will be coming and gas will be going, and where this is the biomass, and this is the open top also. It can be closed depending on the situation. So this is having a mixed between the updraft and downdraft, but this is not being used very much, and it is quick response to fuel supply load and designed poor quality of producing gas. This is the problem with this. And if you look at the downdraft open type, tar is very little, therefore it is used for engine application. Turn down ratio is 4. Whereas the downdraft close the little at a full load, not too low at the lower. This is turn down 3. But the updraft also is a poor in tar, and because a lot of tar will be there, turn down. But the cross draft is a reasonable, tar. It's better than the updraft, but however, the turn down ratio is very low. A narrow region in which it can be operated, the turn down. And there is a powdery biomass which can be, in that case, the rice husk or any other ash or the petroleum fuel or the wood or any other material can be used. The temperature which can something 1400 degrees Celsius. And that, of course, petroleum fuel, you will be getting a lot of energy, whereas this is a low calorie value energy fuel which you can get. So let me talk about the fluidized bed. In this case, this is being used very much in the reality. I'm like, if you look at most of the modern technology are basically on that, because of the fact that it can handle any kind of materials. And but the problem with this kind of thing is that it has to be in a little larger scale, because you'll have to give a lot of systems so that this will be fluid, that floating, this powder, and the particle size has to be very one. And there is a catalytic option. That means catalyst is being used. The catalytic gasification is really a lot of work is going on outside country, but we are not really doing much about it, because the gasification and the what you call pyrolysis, other things people have started looking at, but not in a very big way. That is the problem with us. And even there is a there should be concerted effort to do that, and there should be filter technology is one of the important here. So also cooling technology, and this is a cyclone. Cyclone technology is a simpler. There's a wet scrubber, and then other things one can go for. And this again you'll have to clean with the help of a scrubber. So the advantages with this thing is that fluidized bed, the various type of well without any modification can be used, and lower bed temperature. Therefore, the low NOx you can get, lower maintenance cost, quick cold start with auxiliary gas burner. There's a lot of auxiliary, so you can start very quickly. Whereas the other fixed bed, you'll have to take few hours to start. Superheated steam can be obtained even at lower loads, suitable for combined cycle power plant. This is good. This is being used. And there is a technology which is very well proven in Western country, the circulating fluidized bed combustion, and that has to be, that can be used for even for our handling the solid waste materials. Okay. So if you look at how to utilize this thing, it can be used thermal power and the power. And if you look at the thermal power, can be boiler steam turbine or a gasifier based. In the gasifier, it can be the reciprocating engines. It can be gas turbine engine. It can be mechanical wastewater pumping and electricity. All these applications, stove applications for the thermal. It can be domestic. It can be industrial. And gasifier can be basically a gas burners, or in the large combustor can be used, even the boiler, even the steam engine, which was a very ancient technology, old technology. But I always believe that India should have the steam engine, which is a very smaller one. And of course, you need to redesign, but unfortunately, we don't do anything. So applications, I think there are several kind of things: cooking, forward processing, food processing, and crop and tobacco, drying, brick making, glass making, ceramic pottery, non-ferrous melting, fertilizer production. A lot of things, application you can think whatever it is. Water pumping, wood cutting, grinding, rural electrification. A lot of things can be done with the application wise. And I think I will skip this portion. There is a one gasifier system, herbal waste as a fuel. See, this is where I had used, I had involved in earlier time, that what is the herbal waste in the companies, right? And this will be dried first because a lot of moisture will be there, and then you will have to make a briquetting. Briquetting is small, pressurized, and then it's a dense fuel, and you'll have to store. And then of course there will be oil fired. This is a Nestler company, like boilers, and where there will be hot air you can use from here itself. And then there will be gas cleaning system, cyclone, and there is a basically this is what is being used from storage bin. It will come to get down draft gasifiers. So this is the cycle what you can do, and this is already being developed by the particularly the dairy people, and I was involved to some extent in this work. And economic of, if you look at the herbal waste, is 15 tons a day, and briquetting produce something 5.4 tons a day, and rating was something 981 kilowatt. And these are the, at that time, maybe something 20 years back, it was 30 lakhs costly, but now it will be much higher. So this is a thermal application where I have developed these burners for them, and then we have developed this burner. And it's a dairy gasifiers. And this again maybe 22, 23 years back I'm talking about. So this is a mechanical electrical power system, OD biometric system. This is from ISC Bangalore, where I did my PhD. So this is a system which was developed basically Professor H.S. Mukunda and his group. And it was placed at that time in several things. And I'm like, And the other thing, what I would like to talk about gasification, this is a very recent one which is coming up. I don't know whether anybody in India is working. It's a plasma technology. What is being done is basically the gasifier is a similar concept, like, but the thing is that it is being used the plasma touch, which is having a very high temperature. Even the metal and other any material can be used. That is the beauty of this thing. And this technology must be developed in our country. And you see, air blown, it can be air blown, it can be oxygen plant, it can be oxygen can be used. And any material, mining waste, coal mines, any other things can be used. That is the beauty of this technology. And high availability and higher conversion, 99% organic matter synthesis gas, what is being talked about. No char, ash, residue carbons. Of course, it's all being converted, only producing glassy slag, which is beneficial well. That means the slag, because the high temperature, slag will be converted. People are claiming to be beneficial. Now one has to look at it, whether that will be causing any problem. Because always, whenever the technology comes, they always talk about big things, right? Just to sell the product. But one has to be careful. Complicated with new resource standard like nitrogen oxide, sulfur oxide, particularly, like Environmental Pollution Act has to be looked at it. Higher thermal efficiency, lower carbon oxide emissions. I think I will not agree with this, because depending upon the carbon, it will be converted. Nobody can really say on it. People may say, but whether, and of course, if it can be converted into more CO, maybe the carbon dioxide emission will. But from the plant point of, from power generation, then definitely it will be the carbon dioxide emission need not to be low. Low estimated capital operating maintenance, that is the claim what people always talk about. So now I'll be maybe coming to the last topic, that is the anaerobic digestion. Professor Mandal, is it I will stop over here, or I will take?
Sir, this anaerobic digestion, just to cover the overview of this anaerobic digestion.
Okay, that is being done by the other people. Okay. So maybe within, I think this is the thing. One is anaerobic digestion, which is a very well-known thing, and this is about some biomass. We can talk about some representative chemicals, and it is carbon dioxide and methane. The methane you will be getting gas. So this is the plant. What we say, gobar gas. That is very old and basically kind of things, and it is a waste digested. It can be batch process, it can be continuous. Now people are talking about the sludge will be coming out, and you'll have to use basically waste input, and then supplement gas can be out. And let me tell you, this is the thing which is being used earlier, long time back, when even I was a child in a school college, I had seen that, but still that technology has not been taken care properly. So what is the thing? I'll talk about this, and then maybe I'll stop over here. That methane is a large percentage, but there is a problem with the carbon dioxide, right? It's a problem. So it can be from agricultural waste. These are the data. And there's also another important thing is the hydrogen sulfide. That two problems are there with this. And the calorific value is very low. It's something around maybe 5,500 kilocalories per meter cube, even lower than that. Even some people claim it is 4,500 to 5,500 kind of thing. And landfill will be much also lower sometimes because of the depending on the constituents. And if you look at how to enrich, that is the questions. Generally, people use various, because nowadays people are talking about how to enrich the biogas. The sodium hydroxide is being used, which is very cheaper, and calcium hydroxide. Of course, sodium carbonate can be used, ethanol amine can be used. So that is the what I've taken this from here. That is the plant. What is being this study? What is so that there is a two sample he has taken. One is the process the biogas digesters. From that you will be giving. Of course, they are using for rural area pedal operated compressor. That is very good. And then the column one will be containing sodium carbonate and steel wool. And the column 2 will be calcium hydroxide, and column 3 will be steel and silica. Basically, this is a very simple. I like this thing because there is simple chemicals are used which are very cheaper and which is available. For example, like reaction occurring the carbon removal is sodium hydroxide, right? Kind of things. And so that the sodium carbonate can be coming, and then this and another way of, because if you look at carbon dioxide is converted into carbonate, and this solution of calcium carbonate of water can be used to carbon dioxide removal. So this is calcium calcium basically hydroxide can be really used. This is nothing but your lime water, and then you can get the calcium carbonate later on. Similarly, what is being used, this is in this technology, the iron, chips from the lathe machine or some machining shops can be used. And then when you come with that, and then you will get the ferric sulfide, and then that you can, whenever it will be exposed to the oxygen in the air and the thing, you will get the sulfur. So that is the beauty of this simple technology which can be utilized. And moisture, of course, can be removed by using the blue silica gel crystal. So of course, the raw sample, what they got is something methane has gone off, is a purified something around 95, 96%. And so also carbon dioxide has been really what you call removed, or it is not there as such, and moisture is being reduced, hydrogen sulfide reduced, and so that your calorific value will go up. And if you look at, this is the sample, what I think, methane was the 57 point, now it is 96.91, all this, as a result, the calorific value has almost doubled. It's not double, but nearing to double. And the efficiency, is what is saying that is a very higher values what they are getting. So, and this is already, there is a company which is coming up in the this thing, biogas purification, bottling. They're also bottling the plant so that it can be. And there is a potential of the company, and which you look at the Maharashtra and other things. So this is the number of plants already being put, what they are claiming. And then, so coming to the conclusion, right, the incineration, pyrolysis, gasification seems to be low cost technology for converting waste to energy. Of course, the plasma technology will be little costlier, but if you can make it in indigenously, then cost will be reduced. And the fixed bed gasifier technology can be used for both small and large scale power generations. And biogas technology can be used in rural areas. Indigenous technology for converting waste to energy should be developed so that we can. But the very important thing, what you call the how to reduce the waste generation, because the country is having a population of 135 crore. Unless we change our lifestyle, and of course devising appropriate model of development, unlike just copying the Western people, and we'll have to develop ourselves. Of course, who will build the cat is $1 billion question that I'm leaving with you. And thank you very much listening. Now, if you are having some questions, we can have. Thank you very much.
So is there any query you can ask? Sir is now present. Okay, please unmute and ask your query.
I think there is no question.
Okay, so sir is correctly says there is no question at all. So
I'm expecting something because
yes,
it looks
yes,
to
sir.
me maybe.
Yes, sir. Good morning, sir.
Namaskar.
Yes. Sir, actually, it's not the query. At the beginning of the session, you have asked the participants the question whether our ancestors have carried out the mining process or
Yes.
whether the mining process has carried without any generating more waste. I need the answer for that question,
Okay,
sir.
fine. See, the mining is, if you go back to your Artha Shastra by Kautilya, okay, there's evidence. So the
Okay,
mining
sir.
was going on even, and that is the evidence what we are having. If you go to the Indus Valley civilization, there are several metals used which are excavated. Okay, these are evidence based, not some stories. Okay, that
Okay,
means
sir.
they were doing mining. From where they will get metal? It's not that God will come and give you metal. Okay, not that way.
Okay.
So therefore, they were using, and they were having the technology. Of course, we do not know what they are doing. So
Okay, sir.
therefore, they never really spoil the thing. Okay. But we are doing, I don't know whether any of you have visited mining place. I have visited. You will see life pathetic there.
Okay.
Okay. We are very great, we are sitting in the urban areas, but the kind of people live there and then around that place is really mind-boggling. Why? Because we are becoming a very, very, what you call, maniac and the profit man, and also like we don't have concern for anything, right? So
Yes, sir.
that is the crux of the problem, is the inhuman approach to the life, and we are confused people. No, we do not know what we are doing, right?
Okay. Okay.
And why it is so? Because of bad education. Okay, coming to the point.
Okay.
Right. So
Thank you,
is there
sir.
any other things? Any of you are exposed to this kind of gasifier technologies and then pyrolysis and combustion systems earlier? Now I'm asking a very simple question. There's nothing, whether you are earlier knowing this thing or this is a new things to you. That is, I'm just curious to know.
So actually, we know that terminologies, but in detail, what you have explained, அப்படிங்கிறது, it's a somewhat more than what we know.
Okay. Is it the people are background of chemical engineering or the all?
Some people from chemical engineering, and some people from civil engineering, some people from mechanical engineering, even also some people from electronics and electrical department.
Oh.
Because this waste is common for all these programs.
Okay, I understand.
Okay, sir.
So
yes, sir, please.
There is no question, it looks to me. Because when you talk and no question means, I feel bad.
Okay, sir.
Anyway, that is okay.
Okay. So,
but let me tell you one thing. I'll quote one of my poem and then we'll close. The question is very important in the life. I have written one poem. Name is Question, and that is the first stanza. I will just read for you. Question can never be a silly. Question can never be a silly. It can be a beautiful lily in the garden of knowledge. That is the truth age after age. That is the truth age after age. What is happening today? People have stopped asking questions. Stopped asking questions. They're not questioning themselves. They're not asking questions to others. That is the norm, what is happening in our society. That is really, I'm little concerned, and particularly when I ask this thing, even if we invoke, people are not asking, because there are several questions one can ask here. Okay. Anyway, so thank you very much listening to me, and wish you the best of luck for this course and also your life. Thank you very much. Sabko namaskar.
So thank you very much, sir, for your topic. That topic is very much important for us, obviously, because waste to energy, that is very much important for us. So we have to manage our waste. So today, sir is already elaborating how to extract energy from the waste, and that is very important for us in detail. like the process like incineration, pyrolysis, and gasification. Okay, obviously we are benefited. That is our conclusion of this lecture. So once again, thank you very much, sir, on behalf of our participant, on my own behalf, thank you so much. So one announcement, so in the next session, we shall start from 12 o'clock. So please enter using the same link like yesterday. So we'll start from 12 and we'll continue up to 1:30. Okay. So thank you very much. Should I leave just now? Your permission is very much important for us. Should I leave?
Yes, sir.
Okay, so thank you so much. So again,
Thank you so much, sir.
So we shall meet around 12 o'clock, and that is very important for us how to analyze our liquid waste. So we shall show you some of the, not all the experiment, some of the experiment. Most of the instruments are available in our laboratory for analyzing any effluent. So we shall try to show this instrument. Obviously, the process is called the demonstration, live demonstration. With this, thank you so much.